You first have to go back and remember, tragedy. You have to remember how to do regular long division.
Okay, I got a real bad one.
Okay? And we're going to go over it, but I'm telling you, I know you learned this in 5th grade because my daughter's in 5th grade and she's doing this right now.
What?
So does she teach you?
She teaches me. All right, so think about this just a second, and I'm going to go through one, and then we're going to run the same problem down to along the side to show you how it corresponds to a polynomial long division. So let's just review for a minute. If you were doing long division here, and you're telling someone, Gil, if you don't put that up, I'm going to take it.
You start at 12 and it goes in there twice.
But so you're explaining this to a 5th grader who's never done it before. No, I want you to tell me first what you would tell them to do.
You'll be like, see how many questions, see how many times.
Y'all are real excited because you know the answer.
You
Lily?
go to 12 and you take out 2 5s, which is 10. You have 2 left over and you bring down the 7.
Oh my goodness.
That's for a little 5th grade of mine. I would be like, how many 5 going to 1? And then be like, none.
You take the number on the outside and you say, what do I need to multiply it by to get it as close as I can to this, right? 2. Where does that 2 go?
10.
Above the 2. Okay. Now where does the 10 come from? What are you doing? I want you to.
I have the answer.
I know, we're not worried about the answer right now as much as the process of getting the answer. But nice effort there. It's much appreciated. All right, so it's 10, and we write it here, right? Now what do you do?
Subtract 12 from 10.
This is a subtraction problem, right?
And you want to know what the answer is?
Bring down your 7. That'd be 27.
It's 25.4.
Man, that air's
All right, listen. Now the process starts all over again, right, guys? What do you multiply this? Oh, you got to bring 7 down. That's right. What do you multiply this by to get this? 5. Up top, and now do everything again. Multiply. I don't want any decimals, though. We're going to talk about a different way to do it. When you subtract this, yeah. All right, so listen.
Bring it 0 down.
Here's the question I have for you. If I want an answer without a decimal, first of all, what do you call this number? This leftover? A remainder, right?
25 from big dog. So what again? Like
You bring a 0 down and you put a decimal point after the ball.
Most of you are accustomed to putting a decimal, bringing down, and adding zeros. We don't want to do that. We want an exact answer. So we make the remainder into a fraction. And here we say that's 2 over whatever's on the outside.
More complicated. If you literally run down a 0,
DeAndre?
5 times 3.
oh, there you go.
Thing before we actually start, I need to talk to you about, and that's a placeholder. Remember, this whole chapter has been about polynomials. Chapter 1 was quadratics. Chapter 2 is polynomials, which means more than one piece. So if I have something like this,
You're going to select.
okay? No, I'm not doing any of that right now. I want to make sure that every exponent is there. Okay, I need every exponent. What I mean by that is start with the biggest, and from the biggest, I need to make sure I have every one below that. Okay, so if I have 5, I need to make sure that I have an exponent of 4, 3, 2, 1, and a constant. So when you look at this, what's missing?
The 4.
Definitely a 4. So what I'm going to do is I'm going to insert what we call a placeholder. I'm going to put 0x to the 4th because that's just 0. Now I've got a 3. I've got a 2. I need a 1. So I'm going to do 0x to the 1st power. And I've got the minus 5. Now I'm ready to go on that.
What in the world?
I did this in Florida.
Okay. So right now I need you to know what a placeholder is. It holds the place of what's missing.
You always add 0?
We're always going to add, yes, 0 holds the place there.
X4 and the X1. We gotta have an X4.
You gotta have, you take the biggest exponent and you gotta have every exponent below that. So because the biggest exponent here was 5, then
5, 4, 3, 2, I get
you see? Okay. All right, so before we start any of these problems, everything must have a placeholder if it needs it. Okay?
Everything got it?
Everything we do. Here's what these long division problems are gonna look like. Still need a minute? Okay. I'll give you a second. Don't freak out on me when you say this.
Let's make it.
What?
He wasn't done talking.
You weren't done. We're going to take this function, 3f of x. Remember, that's just function notation. That just means y equals or anything else. It just tells us it's a function. 3x to the 4th minus 5x to the 3rd plus 4x minus 6. And I'm going to do divided by x squared minus 3x plus 5. All right. I'm going to put some parentheses here. And in fact, I'll take this f of x off for right now. We'll get to that in a minute. First thing I want to do is I want to check for placeholders. Okay? Always, 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 the first thing you do is check.
They have to be in order too, right?
For placeholders, yes. So looking at this, do you need any placeholders?
No. Yes.
Where do you need a placeholder?
You need to, and you have to make a job. Move. Two on the other side of the equation.
No, because this is being divided by. I don't have an equation here yet because there's no equal sign.
Like right now?
What?
Let me teach a class.
No. Okay, now here's the next question I have to ask you.
I want to Christ.
If I look back at this example that I just did first, and I wrote this as a division problem with the little division sign like I just did, it would be 127 divided by 5. Do you agree?
Yeah.
So what I'm getting at here is you need to know which one to put on the outside and which one to put on the inside.
The first one goes on the inside.
Exactly. So this one is the outside. This one is the inside. Complete with placeholders. If you have colored pencils, this might be a good time to bust them out, help you follow your notes. Because these take up so much room, I'm going to go to the next page to set the problem up. Yeah. If you don't like your notes to continue from one page to the other and you're towards the bottom of your page of notes right now, you might want to flip over to a fresh sheet. It's going to be long. It's going to be long. Brace yourself, okay? All right, so I'm going to go I'm going to go ahead and set up.
Wait, is it plus 0?
Yes, it's always plus there.
What is this test? Friday?
Friday.
Oh, it's gonna be on.
Yes, this is the one.
Friday like that. Like other teachers that sometimes they're just like, oh, I'm gonna get them off the day today. Ruin their lives. That's Miss McGee did that.
All right.
Like a pop quiz, Miss McGee, like the other day you pulled on us.
You want one today?
No.
You'll have a pop quiz on this probably Thursday.
You give us a pop quiz today, or they call something.
An announced pop quiz. Well, I told you we're going to do quizzes over each concept now. Running right alongside here, I'm going to do our 5. I'm going back into, what was it, 127?
Yeah.
Oh, okay.
Because I'm going to show you how these steps coincide. All right, so we're set up. Placeholders are there. I've got everything I need. I'm ready to go. Look at your example with the 5. I told you to tell me, just like you would tell a 5th grader, what it is that you do. You said, see how many times 5 goes into 12. What do I multiply 5 by to get close to 12? When I'm over on this side, here's what, and here's the key to these. You only use first terms every time you do it. I'm going to look at the first one here and the first one here. What do I multiply this one by on the outside to get what's on the inside? 3 what? 3x2. What do you need to multiply x squared by in order to make it 3x to the 4th? It needs a 3 and it needs 2 more x's, right? Think of these as columns. This is the 4th column, the 3rd column, the 2nd column. So I'm going to come here and I'm going to put a 3x2.
Wait, why you put it right here?
This is the squared column. Anything with a second exponent is going to go in this column. If you want to think about it like that.
That's why we have x to the second. And you're trying to get 3x to the 4th, so you gotta double it. 3 times 1 is 3.
All right, everybody look. I've done one step. All right, look.
Give me a
Because
second.
you do it by the first number and the first number inside. First number outside.
You're only looking at first terms.
I think that's
Over here, we said, what do I multiply 5 by to get as close to 12 as I can? And we said it was 2 and put it up here. So on this one, I said, what do I multiply x squared by to get? Okay, so 1 needs to be multiplied by 3. And then I've got x squared here, so I need another 2 x's to make it look like that.
Now we're gonna go to 3x.
No.
You gotta go down, right?
Nope.
Wait, I got a question.
Okay.
Would it be 3x to the second? Is that like where you're gonna put that?
That's the first term in your answer. That's what I wrote at the top. All right, now look at this. Look at this example. I'm telling you, the steps are exactly the same if you follow them through. What do you do here once you figure out the number that goes up top? You multiply it and write it here, right? Okay, now watch carefully. I'm going to take this 3x squared and I'm going to multiply it. But it's got to multiply to everything. Remember the unit that we did on multiplying, adding, and subtracting polynomials? Shh. So this is the same thing, okay? I'm going to take 3x squared and multiply it to this. In other words, I'm going to distribute it.
I get it.
Okay?
Rewrite problem over again.
No, we're going to do it the way it sits so we don't have to use so much room. But what I'm going to do is, what is 3x squared times x squared?
3x squared.
3x to the 4th. Remember, I'm going to write them in the corresponding columns. What is 3x squared times negative 3x? Negative 9x cubed. Remember, we add exponents when we multiply. And what is 3x squared times 5?
15. Now it's you for all of them, right?
No. All right, go back to your example. When we write this number here, what is the next? You subtract, okay? So here, I'm subtracting this to get 2. So on my example here, I'm going to subtract, but here's, I'm subtracting everything. Remember when we subtracted polynomials and we had to do same, change everything.
Wait, what did you say again?
Remember whenever we had polynomials set up and it would look like this, 3x to the 4th minus 5x to the 3rd plus 0x squared minus 3x to the 4th minus 9x cubed plus 15x squared. We did same, change.
See, that's just a lot to write.
Change everything. You don't have to rewrite it out each time. It's already written there for you. I'm just showing you. We did it in a horizontal format. Now you're doing it in a vertical format. And then we just combine like terms. The nice thing about this format is your like terms are lined up for you, because we're keeping everything together.
But you gotta change everything.
But I got to change everything because I am subtracting.
Whoa. Why do you do that?
You didn't need it.
I don't need it. I'm doing it here. I'm just... Okay. Oh my goodness. Sorry people watching the video. We same change everything. Okay. I forgot to hit record again. Okay. So if you've done it correctly, your first term should cancel out every time.
Hold up a second. Hold.
The first one takes us forever to get through because I'm explaining as we go. Don't think they're all going to take this long. You'll see. The first one seems overwhelming. Then we'll work one all together in just a minute and you'll go, oh, it's not even that hard. Trust me. It happens every time I teach it. All right. So look, I've got, this was a negative 5x cubed. You can't, I was drawing that little green line, but it is negative. Plus 9x to the third gives you 4x to the third. What is 0x squared?
So, Ms. McGee, do you change the
Watch this
one
video
that
like
was
100
green,
times
right?
and I still won't get it.
Change what?
You change the number that was in the green.
Yes, yes, all those changed.
And you keep the
Yes,
Oh, and then we're just gonna have negative 3
Yes.
squared, correct?
correct. So now it's minus plus minus.
Bring down the other stuff.
I changed it in pink. All right, huh? Yep, y'all are getting a step ahead, but that's exactly what we're going to do. If you look back after you subtract, the next thing you do, bring down the 7, right? So I'm going to go back to my problem and I'm going to do the exact same thing, only I've got now a 4x. Okay? One at a time, just like whenever you're with the regular problem, if this had more numbers, you just drop one at a time. Same thing on this one at a time, okay? Now the process starts all over, so it's a repetition. So what do I multiply this by to get this? 4x, just 4x. I need a positive 4x, right? A positive 4x.
Wait, what? How did you read that?
All right.
From the top.
Both first terms, you're only looking at first terms. What do I multiply this
Bring down
by
the 6.
to get this? Yes, Phoenix.
X squared.
That 3x to the second.
What?
Or do I still need that?
You still need that. That's part of your answer. Because you need it to equal 4x to the third. You've got 1x to the second. So you need a 4 for a coefficient, and you need one more x to make it a third power. All right, same process, multiply around. What is 4x times x squared?
4x squared, 4x squared.
This is too complicated for me.
It's really not as complicated as you think it is, I promise.
This is one problem you're gonna have just like 30 of these on homework.
4x times negative 3x is?
12.
And 4x times 5?
Hold on now.
Okay, look, if you get confused, remember you are just taking this and distributing it to everything outside.
Jesus Christ.
Again, subtract. It takes a couple of these to get the pattern down because you're doing the same thing. It's over and over. There's really 3 steps that you're just continually repeating.
Don't you change everything?
All right, yes. Same, change, because I wrote this book and I made the standards on what I should teach
Some
you.
common 4 algebra 2.
Yeah. 4x cubed.
Hold up.
All right, hold up what?
Minus 16x equals, or minus 6.
It's negative 3x squared because it's negative 15 and positive 12. The nice thing about these are your like terms are lined up right beside each other. You don't have to start searching for like terms. They're there beside each other. 4x and negative 20x.
It's gonna be on our test.
Yes.
And get every single one.
This is easier than I think I'll get.
I told y'all before I started I was gonna have to pause this video like 100 times while y'all complained about how hard it was, and then we're gonna get. I'm telling you, we haven't even gotten to the example yet that when everybody's gonna go, oh my gosh.
What?
Bring down the next term.
You just need to start letting us do class work.
It's negative 3.
So this is minus 6. So now same thing. What do I multiply x squared by to get negative 3x squared? Negative 3.
I'm gonna mess up right there. I'm gonna
Yeah,
mess up.
that's what's confusing me that hard.
So go down.
So you keep using the first
And that was it?
It's always only the first piece. That's all you ever look at when you're trying to decide what to put up there. All right, no, that's not it yet.
Why is the x squared not there?
Because the first one already has an x squared on it, I don't need any more x's. The only thing I need is I need this 1 in front to become a negative 3 instead of the one that it is. So what do you multiply 1 by to get negative 3? Negative 3.
Now we're out of numbers.
Wait, what make we getting 3? What?
All right. I'm back. I'm repeating the process again.
I have no clue how to do this.
Okay? You continue the process until you can't anymore. So watch. Multiply it around. What is negative 3 times 1x squared? What is negative 3 times negative 3x? What is negative 3 times 5?
Negative 7x minus.
I'm subtracting here, but I need to go same, change, 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 change.
Hold on.
Holy crap.
Wait, this could be.
I promise we are almost done.
With what? Negative
15x plus 9.
The first terms cancel. What is negative 16 and negative 9?
Why would it not be negative 15?
25.
Why wouldn't it be what?
No.
No.
Oh, that's a 16.
So when you plug it in, you don't even put a sign in at all?
When I plug what in where?
Like, so the bottom. The bottom where I'm the same change thing.
Yes.
Keep the top the same,
Correct.
but if we were to wrote it like, it's like, not, it's 3 times 3x equals negative 9 to begin with.
Fido's coming today.
Well, but it's two negatives, so two negatives make a positive.
Okay.
If you need to write it out to the side like this until you start getting the hang of it, then do that.
And then 15 is a positive, so why would it not be a negative?
You're multiplying by negative 3.
No, it's negative.
Can I multiply x squared by anything to get negative 25x? No. I can't multiply x squared by something and get it down to x. So therefore, this is my remainder. Okay? I'm going to flip back over to this example that we worked earlier. And we did it as a fraction here, right? We're going to write this as a fraction on this one. So we're going to say plus, we're going to take the remainder, negative 25x plus 9, over what's on the outside. So it looks like a lot with that remainder, but that remainder is just writing what I have left over what's on the outside. So that's the answer. So that tells me that this divided by this equals this.
I got none of that at
Put
all.
the,
It's just a bunch of lines.
The other thing, isn't there, like,
It really.
What?
That's
the other thing they got next to us?
Yes, but it wouldn't work with this problem. It only works with certain problems, and it wouldn't work with
No,
this
it
one.
only works with the problems that don't have.
We just like,
Don't have exponents or coefficients on x, yeah.
we skip
Nope.
this section. We skip this section, this is
Yeah.
too much. Not really.
Yes.
I'll be there.
This tells me that this, whenever I divide this, it gives me 3x squared, what was the, plus 4x
We draw a line.
I'm not
minus
gonna do
3
it.
plus
If I get that far.
25x plus 9.
Almost fine.
If it wasn't math, it'd be fun.
No, it's not fun at all.
I want you to understand the interpretation here. When I divide this, this is what I get, okay? All right, let's do one more together, step by step, and then I'll give you one to do on your own.
I was gonna do step by step. Let's look up so much table.
Lily, I'm going to do one that you could do that shortcut with, but I haven't talked to you yet.
So
So.
we just do like regular long division, like none of that X stuff.
Wait, why don't you teach us since we're doing
Yeah,
adding and
fine.
subtracting?
Which one will we use in real life and which one will we
Teach you
not?
what?
Yeah.
This, well, we're doing adding and subtracting.
Adding and subtracting polynomials is on this test.
Oh.
It's adding and subtracting polynomials, multiplying polynomials, dividing polynomials.
Wait,
So it's just polynomials.
It's all together.
Yeah, factoring is a form of dividing.
I know, but did you guys learn adding and subtracting polynomials?
Yeah,
You did?
yeah.
Was that like the 4x squared minus 9?
Yeah, you were definitely here for that.
I don't get it.
All right, so it's set up. Do I need any placeholders here?
Hold up.
No, yeah, do I? No. 3, 2, 1, nothing, and then I've just got an X and a 2, so I'm good. So it's time to start the process.
Alright, I'm actually gonna pay attention to stuff.
You do
This one?
x
Wait,
squared
this one's
times x.
Okay.
This one's going to be longer, but there's less on the outside of this one. It's going to take more steps to get through
So
it.
it's x, it's x to
Hold
whatever
up.
going to x is third. So it's gonna be x squared, right?
Okay, so where's it go?
Hold on, hold on.
Right on top.
Over 5x.
I gotta get close.
X.
Hold up.
Ah! I forgot to hit record again, guys. Sorry. We multiplied around.
Whoa, you went to, why did?
Okay, so I multiplied around. Look, x squared times x squared times negative 2. Now I need to subtract both of these.
3x, 4.
Same, change, change, change.
Hold up.
Oh,
Too fast.
I'm messing up with the x, but
Cause they ain't still two.
What?
3x.
Yeah, it's still 2.
3x.
What?
For the
What?
answer.
When you pull your exponent.
Plus, you gotta do plus 2x squared, so it's gonna be 7x squared. Because you had to change because you're subtracting. Remember we had to do same, change, change, change.
So that was supposed to be a minus sign?
Yeah, because of the minus sign here on the outside. It was negative to start with, we changed it to plus.
Then do you bring down the negative 7?
Alright, 7x squared. Yes, bring down the negative 7x.
Did you give Lexi, ISS too?
Now, Gil, why don't you understand that I cannot have,
A number.
And you go 7x to the second. Multiply
what do I multiply this by to get this?
7x.
Positive. Because this one needs 2 x's, and I've only got 1 on the outside. Okay. All right, multiply around. 7x times x, and 7x times negative 2.
Okay.
Same change.
Hold on, please.
Yeah.
Still not gonna be able to do this by myself.
Same, change, change, change.
Ain't smart like that no more.
Negative 7x plus 14x is 7x.
Bring down the 2 plus 2. 7x. 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 7x.
Same thing again. What do I multiply this by to get this? 7. Yay for everybody answering in unison now.
Not me.
7x.
I got the answer.
Multiply around. 7 times x is 7 times negative 2 is
Okay, so is it x to the second, or is it x squared plus 7x plus 7,
We're-
16 over x2?
yes.
Minus 16.
So we start.
Same change.
Let me get like that.
2 and 14 is, there's nothing else to bring down, and there's nothing I can multiply x by to get 16, so that indicates that 16 is my remainder.
What happens if we have to?
Okay, I get it now.
16 over x minus
Yes.
Yeah.
We will?
It makes sense.
What's your question, Dwight?
No, you just said do multiply x.
People watching the video, we are now trying one on our own.
That's the story